Hi guys, so we look at speed time graph. So under speed time graphs, these are graphs which show the speed of an object with time. Remember from our previous video, we have looked at the distance time graph, where we said these are graphs which show the distance covered with time. Now in this video, we are looking at the speed time graphs. Now these are graphs which shows the speed of an object with time. What are we trying to say? The gradient gives the rate of change in speed, and the meaning of the gradient in this case is what we call the acceleration. Now acceleration is found by saying the change in speed with time. So it is the rate of change of speed with time. So we have this graph here which I have just drawn here. This gradient here, the gradient, the steepness of this is what we call acceleration. So this is acceleration, okay, because the speed here is increasing. Now, when we come to this one, we have also this one here, this part here. This one, it is known as the constant speed or constant velocity. When you look at this part here where the y-axis have written speed, which is in meters per second, or velocity, it is also in meters per second. So, now, we have also this part here. Remember, this one is coming from 0 going up, meaning it is increasing. The speed is increasing because this is 0 meters per second. This one can't be 0. It can be probably 1. This one can be 2 here, can be 3 here, meaning the speed is increasing. So, this is the reason why. Now, when we reach here, this is the constant speed because the speed is not increasing. This is the graph we have. Now, we also have this part here. So this part, it is known as from this statement we are saying if acceleration is negative, it is called deceleration. If acceleration is negative, it is known as the deceleration or retardation. So this means that the speed of an object decreases. So from this point here, the point we have there, up to this point here, the speed is not increasing, but it is reducing. Remember, we are coming here, it's same as from here up to there. We are coming from the higher speed to a 0, meaning the vehicle or anything or an object, the speed of that object or the vehicle, or it can be a bicycle or anything, it is reducing. The speed is reducing. When the speed is decreasing or reducing, it is known as deceleration or retardation or negative acceleration in other books. So, what else do we have under the graph of the speed time graph? We also have the area. The area under the speed time graph gives the distance. Now, this means that, remember, I said speed is equal to distance over time. Then I said something like if you are looking for the distance under distance time graph, you just say speed multiplied by time taken. But in this case, under speed time graph, when you are looking for the distance covered, you must first identify the area under the distance you are told to find. What am I trying to say? For example, I think you to say find the distance from 0 up to here, meaning you must come up with the area of the shape formed. So when you look at this shape here which has been formed here, this is a triangle. So you use the formula we use to find the triangle of the area of the triangle. Now, sometimes you may be told to find. Now, before I go to sometimes, The area of the triangle is 1/2 BH, where from here up to here it is the height, then from 0 up to this point here it is the base. So this is the formula. Now, sometimes you may be told to find the distance from this point up to this point. So this point here, it is another issue where you have this. Maybe I can say x2. Then this other one here I can say x3. So what kind of a shape is this? So this shape here is known as a rectangle. Meaning to find the distance of from here up to here, the distance covered here when the speed was constant, you find the area of the rectangle. So the area of the rectangle is L times B. So in this case, our length, maybe I continue this one as our B. Then now, the height here, it will stand for the length. Or if you don't mind, you can say area, let me use the word O. Area is equal to base times height. It will still mean the same. Because in this case, our height will still be this one or this distance from here up here, which is the same, because we are getting the distance from the y-axis. But this distance here, we are getting it from x-axis. So you can use this one to find the area of that. Then you can also be told to find the distance covered when the speed. By the way, this one is known as deceleration. Deceleration. Okay, deceleration. Deceleration, this when the speed of the car or of an object is decreasing. So you may be told to find the distance covered in the last whatever minutes when the car up to the time when the car stopped, or up to the car when the object is stopped moving. So since the shape here is the shape for a triangle, you still use the formula to find the area of the triangle. Sometimes you may be told to find the distance covered for the whole journey. You add the area you find here, you find the area for this part, you also find the area for that part, then you add all of them. Or you get the whole shape like this, the way it is. So this is the shape. Now this shape, it is in the form of a trapezium. So the distance from here up to here, it is known as you can name that one as your A, and then also from there up to there, you name it as your B. Then this one is your height. So the area of the trapezium, it is known as, so the area is equal to, open bracket, then and H. So this is the formula we use. You find that if you use this formula, meaning our A will be the length from here up to here, which is from this x1 here up to x2. Meaning if x2 is 20, you say 20, I'm just giving an example. It will be 20 minus, if this one is 5, it will be 20 minus 5, which will be 15. Meaning your A will be 15. Then your B will be from there, from 0 here up to here. If this is 45, meaning it will be 45 minus 0. Okay, to mean your B. Then the height, it is from here up to here, which is from here up to here, which is the same as from here up to here, which is coming from this part there, our y-axis. So if from 0 up to there, it is 20, meaning you're going to say 20 minus 0. If this, imagine it was coming from here, meaning this one is 5, I'm just giving an example, meaning I'm going to say 20 minus 5, meaning your height will be 15. So you can either use this formula, or you use these formulas to find the area of each shape formed there, to find the distance under speed time graph or under velocity time graph. So in our next video, we are going to look at the examples which comes under speed time graph. Otherwise, thank you so much.